Anzio, Italy, March 1944. 12 German Junkers Ju-88 bombers skimmed the Mediterranean waves at wave-top height, their engines throttled to near idle. The crews were veterans, men who had flown night raids over London, Stalingrad, and Sicily. They knew the tactics: fly low to avoid British chain-home radar, maintain radio silence, navigate by dead reckoning and coastal landmarks. Their target, the Allied beachhead at Anzio, where American and British forces had been pinned since January, vulnerable to precision bombing. No searchlights swept the sky. No sirens wailed. The approach was textbook. Then, at exactly 4 minutes before bomb release, the darkness erupted. American anti-aircraft batteries, positioned miles inland, beyond visual range, opened fire. Not with the usual random flak patterns that peppered the sky in hopeful arcs, but with surgical precision. Shells exploded in the exact airspace the bombers would occupy seconds later. The first 3 aircraft disintegrated before their pilots registered the threat. The remaining crews executed evasive maneuvers that had saved them dozens of times: steep dives, violent climbs, hard turns. It made no difference. The shells followed them through darkness, through smoke, through cloud. In 11 minutes, 9 bombers were destroyed, a 75% loss rate. For the Luftwaffe, this was incomprehensible. German flak accuracy against maneuvering targets had long hovered around 3 to 5%. 20 to 30 shells fired per kill. Now, American accuracy had jumped to 34% overnight. Pilots returned with the same stunned report. They don't aim at where we are. They aim at where we will be. What the Germans could not see, and would not understand until it was too late, was that warfare had entered a new era. Not of bigger guns or faster planes, but of invisible microwaves, mechanical computers, and automated fire control. 8,000 miles from MIT's radiation laboratory, the SCR-584 radar, the most decisive fire control technology of World War II, was revealing itself. Not invisible gunfire, but in invisible pulses the Luftwaffe never imagined possible. The birth of a system, from British insight to American scale. The SCR-584's origins lay in a moment of Allied desperation. In September 1940, as the Battle of Britain raged, Britain's Tizard mission crossed the Atlantic, carrying its most precious scientific secrets, including the cavity magnetron, a device that generated high-power microwaves at 10-centimeter wavelengths. This was revolutionary. Pre-war radars, like Germany's Wurzburg, operated at 50 to 80-centimeter wavelengths. Their angular resolution was measured in degrees, sufficient for early warning but useless for precision targeting. The magnetron enabled microwave radar with resolution measured in fractions of a degree, accurate enough to track an aircraft's speed, altitude, and heading in real time. Bell Telephone Laboratories, working with MIT's RAD Lab, took the British breakthrough and industrialized it. By 1943, they had developed the SCR-584, a self-contained, truck-mounted radar system that combined microwave tracking with the M9 gun director, a mechanical analog computer that solved ballistic equations in real time. The system worked as a closed loop. Radar detected the target in 3D space. Computer calculated the intercept point, accounting for shell velocity, wind drift, target motion, even the Earth's rotation. Guns fired automatically at the precise coordinates where shell and aircraft would meet. Gun crews no longer aimed. They simply pointed their 90mm M1 anti-aircraft guns where the M9 directed and watched shells explode exactly where invisible aircraft would be seconds later. This was not incremental improvement. It was a paradigm shift from human intuition to mathematical certainty. German doctrine, the limits of human-centered warfare. German radar development had once led the world. The Würzburg radar, introduced in 1940, was a marvel of its time, a 53-centimeter wavelength system that could guide night fighters to within visual range of bombers. But by 1944, it was obsolete. Its 1-degree angular resolution meant it could not provide the precision needed for automatic fire control. Worse, it required manual tracking. An operator used a joystick to keep the radar beam on target, introducing 0.5 to 1.5 seconds of human reaction delay. In that time, an aircraft flying at 400 kilometers per hour moved 150 meters, enough to turn a hit into a miss. German fire control remained human-centered. Flak commanders used mechanical predictors like the Kommandogerät 40 to estimate future aircraft positions. The gunner adjusted aim based on experience and intuition. This worked against predictable targets, bombers flying steady courses at high altitude. It failed catastrophically against low-altitude attackers, night raiders, and evasive aircraft. Accuracy rates reflected this: 3 to 5% against maneuvering targets, less than 1% against fast, low-flying fighter bombers. The mathematics were brutal: 20 to 30 shells fired per kill. Against high-speed targets, it was often 100 to 1. The production chasm, industrial philosophy in action. Disparity wasn't just technological, it was industrial. By 1944, the United States was producing 1,500 SCR 584 units annually. Western Electric's New Jersey facility manufactured 400 units per quarter, using assembly line techniques. Engineers broke the complex radar into modular subassemblies, reducing final assembly time from 800 man-hours to 200. Every unit underwent 48-hour burn-in testing. Germany, by contrast, produced 2,400 Würzburg units annually across all variants, and that number was falling. Allied bombing of electronics factories in 1943 to 44 cut German radar production by 40%, just as demand surged. Field units reported chronic shortages of replacement tubes, spare parts, and maintenance equipment. But the real gap wasn't in numbers, it was in integration. American doctrine treated radar as the foundation of fire control. The gun served the radar. German doctrine treated radar as an aid to human decision-making. The radar served the gunner. In the millisecond precision world of anti-aircraft fire, this philosophical difference was fatal. Anzio, the first revelation. At Anzio in early 1944, German bombers attacked the beachhead repeatedly, suffering standard 3 to 5% loss rates. Then in March, new American units arrived, equipped with SCR 584 radars and M9 directors. German loss rates immediately jumped to 25 to 35% per mission. Luftwaffe pilots reported with frustration that American flak seemed to predict every maneuver. Diving didn't help. Shells exploded at the bottom of the dive. Climbing didn't help. Shells waited at the top. Evasive turns meant shells exploded exactly where the aircraft would complete the turn. One pilot wrote in his diary, "It is as if they see the future." The reality was simpler but more terrifying. The SCR 584 tracked aircraft through three-dimensional space, Calculating velocity vectors in real time, the M9 Director solved ballistic equations faster than human reflexes could process. For the first time in the war, German bomber losses to ground fire exceeded losses to fighter interception. This was unprecedented. Ground fire was not supposed to destroy aircraft outright at such rates. The box barrage, networked lethality. The true power of the SCR 584 emerged when multiple units operated together. Unlike German Würzburgs, American radars could share tracking data through telephone and radio links. When one radar acquired a target, neighboring units automatically oriented to track the same aircraft, creating redundant coverage. If one radar lost the target, another maintained lock. Multiple batteries could coordinate fire, creating overlapping kill zones impossible to evade. American doctrine called for box barrages, 3 or 4 batteries firing simultaneously at calculated intercept points. German pilots encountering these reported them as flak walls. Solid barriers of explosions that appeared instantly in empty sky. Aircraft entering a box barrage faced dozens of shells exploding within lethal range simultaneously. The lethality was real and mathematically inescapable. Normandy, the system at scale. At D-Day, the system reached its peak. Over 500 SCR 584 radars covered the English Channel, linked through communication centers. German pilots reported being engaged simultaneously by multiple batteries from different locations, all firing at the same predicted intercept point. One Luftwaffe observer wrote, "It is as if they can read our thoughts. Every turn we make, every altitude change, the flak is already waiting." Allied air forces landed with over 200 radar-equipped fire control systems protecting the invasion fleet. German defenders had perhaps 40 radar installations in the entire Normandy sector, mostly early warning sets. The results were staggering. Allied aircraft losses to ground fire, less than 2% per sortie. German aircraft losses to Allied anti-aircraft fire, greater than 15% per sortie during critical operations. The mathematical imbalance was decisive. German pilots faced automated defenses that engaged them beyond visual range with computer-calculated precision. By early 1945, Luftwaffe bomber operations over Allied-held territory had effectively ceased, not from lack of aircraft or pilots, but because casualty rates made missions mathematically unsustainable. German failure to adapt. Ideology over evidence. The most remarkable aspect of this story isn't American success, but German failure to recognize and adapt. Captured SCR 584 units were examined by German signals intelligence as early as 1943. After the Battle of the Bulge, complete sets were transported to Telefunken laboratories for detailed analysis. Technical reports correctly identified 10-centimeter wavelength, superior angular resolution, automatic tracking capability. They concluded American radar technology was approximately 18 months ahead in miniaturization and automation. Yet German leadership never prioritized matching this technology. Why? Doctrinal blindness. German radar doctrine emphasized early warning, not fire control precision. The concept of replacing human gunners with automated systems seemed wasteful and overcomplicated. Resource allocation. German industry was stretched thin producing aircraft, tanks, and V-weapons. Diverting electronics capacity to advanced radar seemed less critical. Misattribution. Commanders attributed Allied success to numerical superiority in guns, not technological superiority in aiming. They missed that better radars enabled better accuracy per gun, a force multiplier of 100 to 1, not 10 to 1. Engineering culture. German designers valued complexity and precision, Like the Wurzburg's sophisticated optics, Americans valued integration and automation, systems that worked together to solve problems faster than humans could think. Prototypes for German microwave systems showed promise by early 1945, but the war ended before production began. The technological gap, visible in 1943, recognized in 1944, acknowledged in 1945, remained unbridged through Germany's surrender. The legacy, the birth of modern air defense. By 1945, the radar production gap had become an unbridgeable chasm. American factories produced over 2,000 SCR 584 units that year alone, more than Germany's total radar production across all types for the entire year. Every Allied anti-aircraft battalion in Europe had radar-directed fire control as standard. German batteries still relied primarily on visual acquisition and mechanical predictors. The principles established by the SCR 584 became foundational to modern warfare. Automated tracking meets human observation. Computer-calculated fire beats intuitive aiming. Mathematics defeats experience. Networked sensors beat isolated strongpoints. Integration matters more than individual system performance. These seem obvious now, but in 1944, they contradicted centuries of military tradition. The concept of manually aimed anti-aircraft guns became as obsolete as cavalry charges against machine guns. Post-war systems trace their lineage directly to the SCR 584, Nike Ajax Missile System, 1950s. Patriot missile batteries, 1980s to present, S-400 and all modern integrated air defense networks. German air crews discovered this reality over Anzio, Normandy, and the Rhine, learning too late that warfare had moved beyond human reflexes into the realm of automated systems. By the time German engineers understood the SCR 584's full significance in early 1945, the war was already lost, not in dramatic defeats, but in thousands of aircraft that never returned, shot down by guns they never saw, guided by radars they never detected. The story of the SCR 584 is not one of individual heroism, but of systemic superiority. A reminder that in modern warfare, sensors matter more than shooters. Automation defeats intuition. And the invisible advantage of superior electronics determines victory. If you value history that honors both innovation and sober realism, if you believe the engineers, technicians, and gunners who built and operated these systems deserve more than myth, we invite you to subscribe. This channel is dedicated to preserving the real legacy of World War II, not as entertainment, but as testament. Because those who lived it understood a truth we must never forget. In the age of electronic warfare, the system beats the component, and mathematics defeats myth.